Welcome to the video tutorial for creating a thematic map. For step 1, you need to add your data to your assignment project. The first layer or shapefile that you will use is from the City of Little Rock Open Data Portal. You can access this at data.littlerock.gov. Once you're on this website, click on Data Apps and go to Data Catalog. We are interested in the wards dataset. Usually it's the first thing that pops up. If not, you can search for it here and just make sure that you find the wards dataset. Click on it, and here we will click Export and change our export format to shapefile. When our download is complete, we can see it in our Downloads folder, and we can see that the shapefile does not have the best name. I am going to move this from my Downloads folder into my Assignment folder. And I'm going to you need to extract or export the zipped file. I'm going to rename this to Little Rock or LR Wards. And I also hate this name for the shapefile, so to change the name of a shapefile, you can select all of the files for that shapefile, click Rename, and if you rename one, it will rename all. Make sure you download the 11.1 data folder from Blackboard, and then you are ready to connect to your assignment folder in ArcPro. For this assignment, you will create a thematic map. It will be a choropleth map, and it's going to show residential density in Little Rock. The density will be shown based on city ward, so you should think about which of these two layers will be used to display the data in our choropleth map. Let's explore the Little Rock wards layer. Open the attribute table. You can see that there are 7 wards in Little Rock. And if we are going to label this layer when we're creating our map layout, you would use the district field. We don't want to label these wards based on the name of the city director. And we can also see here that we have 2 object ID fields. We have the one generated by this ArcPro project, that's the FID field, and we have the object ID field that came from the shapefile itself. I'm going to go ahead and delete that object ID field and save. And now let's examine the Pulaski County address point. As we can see just from looking at the geometry, this layer has more information than just address points in the city of Little Rock, so we are going to have to use an SQL query to reduce the number of records in this layer. We also need to figure out, does this layer show address points that are just residential or that are residential and commercial? To figure this out, you can either use the map view, which I'll show you first. To do that, you can navigate to a part of Little Rock that you're familiar with. I'll navigate to the Euler area, and I'm going to change my base map to imagery because my brain works better viewing imagery data. So here's Euler, and I know that these buildings across University are not residential, yet we have an address point for those buildings. So that must mean that this layer represents both residential and commercial address points. You can also figure this out by looking at the attribute table, exploring some of these fields. We can see that the address points have their address number or house number. They have street name, street type. They also have a field called vanity. that looks to be blank, but I'm going to sort this field in ascending order and see if it has some values in it. Now I'm going to sort in descending order. It should have values in it. It does. So some of these records have information in the vanity field. And if I scroll through these, I can see that some of these vanities are for something that sounds like a business, like Wonder Nails and Wonder Place, rather than just residential. So these are two different ways that you can use to determine what this point layer is representing. In order to accurately use this Pulaski County address points layer, we need to better understand the information in the attribute table. We can usually gain a better understanding of any sort of shapefile or data layer by looking at the metadata. But if you click on this layer in ArcPro and select View Metadata, you'll see that there's not any metadata information in here. So I downloaded this layer from the Pulaski Area GIS website. So let's go there to see if we can find something equivalent to metadata. Go to pages.org. On this website, under Public Data Resources, click on Data Dictionary. And the Pulaski County address point layer is a renamed version of Pages' BPAD building point addressing layer. So with this highlighted in the addressing box, click on Go, and you will be taken to the data dictionary, which is just another word for metadata. This data dictionary includes information about the purpose of this layer, when it was captured, some of the attribute definitions, and the area coverage. If you scroll down, you'll start to see a list of fields similar to the data dictionary that we created in our field data collection assignment. And we need to figure out specifically two fields. So first off, we need to find which field tells us what city the address point is located in. So when I am on the attribute table looking at the different fields, I can see that there is a field called city code. But if I go to select by attributes and I put city code in that field, I see that the values are just numbers. That doesn't mean anything to me. So hopefully the data dictionary can provide us with more information. So if you scroll down in the data dictionary to find city code, you'll see it tells you the data type. It tells you, so some of these fields will tell you the attribute domain values, and others tell you that you need to see an appendix. So now I'm going to go look at Appendix N. That is back on the data dictionary page. At the very bottom, you have your appendix list. Click on Appendix N, City Codes. And here we can see that the code for Little Rock is 1. So when we do an SQL query, we want our city code to equal 1. Next, we need to figure out what in this layer, or what field in this layer tells us the use type, tells us if this point belongs to a residence or if it belongs to a business. There's a lot of fields in here. Because I'm familiar with this layer, I already know that it is our structure code field. I can see it's a double data type, and that I can find more information about this field in Appendix M. So pull up Appendix M, and here you can see a 4-page document that lists out the structure codes, also called NAICS codes, and their domain value. So the number is the domain code and the text is the domain value. We are interested in finding residences, so maybe you can Control F and type in house. That gives us two options. The first one, personal and household goods, that would be a commercial business. The second one, rooming and boarding houses, that applies. And then if I look above that, I can see that we have other residential types listed. We have mobile home, single family, duplex, 3 different types of apartments, rooming and boarding houses, and dormitories. So these are the 8 codes that we are going to use to represent residential units in the city of Little Rock. And I've included this information in the instruction document to make it easier for you to reference. After examining the data, we learned that the Pulaski County address points layer has more than just residential addresses in this layer. We need to prepare this layer so that it only shows residential addresses that are located in Little Rock. We are going to use SQL to perform a definition query. Definition queries allow you to reduce the number of records displayed in a layer without creating a new layer. Before I show you definition queries, I should just mention that there's many ways to do each thing that you want to do in GIS. So if we want to reduce this Pulaski County address points layer to represent just residential address points, we could use select by attributes to perform a detailed SQL query. And then once we have our records that we care about selected, you can click on that layer in the content pane or right click on it and find the data option. And then you can export your features to create a new feature class or a new shapefile with only those selected records. But we're not going to do that because there's no need for us to create another layer, and I want to show you guys how to use a definition query and the power that it can provide you when you're doing data analysis with GIS. To perform a definition query, you need to right-click on the layer in the Contents pane and go to Properties, and then go to the Definition Query section of Properties. Our definition query is going to be kind of lengthy, the most detailed SQL query you guys have done so far. The first thing we want to do is we want to select only address points that are in the city of Little Rock. So change your field to city code is equal to 1 was our value for Little Rock, and then click apply. When we do this, we can see down here that our number of records in our attribute table has changed. If you load all, you can see that now there are 117,661 records. We're still going to reduce these records because we still have commercial records in this layer. And what the definition query does is it doesn't delete that value, it just hides it. So it has hidden anything that does not have a city code of 1. Next, we are going to add clauses that tell us what structure code we want. So you're going to add a clause. And the first connector that we'll use is AND, because we want to know what address points are in Little Rock and are residential. So we'll change our field to structure code. Oh, it's right there in front of me. And then I will type in our first structure code value, which is 81410. If I click apply, that just applies that. And now I can look at the SQL code. And in here, I'm going to type the remainder of the code using an OR connector because we want to know every address point that is in the city of Little Rock and is one of the following structure codes. So in order to do that, we use the OR connector. Now I have all of my structure code values in here. It's really important to double and maybe triple check your work. So make sure you count and make sure you have 8 structure codes in your query box. I have 8, and then you should probably also check the numbers against the information listed in the instruction document to make sure that you typed in the correct structure codes. Now, we have our SQL code here. However, there is something wrong with this. So when you click apply, oh, for some reason it's working. Let's see. I don't think that, yeah, that did not do exactly what we wanted. And when we go back to the definition query, we see that the city code and the first structure code have been like pushed to the right a little bit. They have an indent. So go back to your SQL code and you can see what it did here. It put in a parentheses, but it didn't put the parentheses in the correct place to return us the information that we want. The parentheses needs to be right in front of the first structure code and then at the very end of your last structure code. When I click apply and I load all of the records in this attribute table, it should return 99,432 records. If you did your SQL code correctly, that is the number that it will return, and you are ready to move on to the next step. If you get a different number, you need to troubleshoot your SQL code a little bit more until you get the right number of records. Our address point layer is ready to go. What we are going to do to determine the number of residential units or residential address points in each ward is we are going to perform another spatial join. Also, if you zoom out, you can see that your map view, the geometry of our address points have changed. Instead of being scattered all across Pulaski County, they are now only located within the City of Little Rock boundaries. To perform a spatial join, pull up your geoprocessing pane by clicking on Analysis and Tools, and type in Spatial Join. We are going to do a spatial join from the Analysis Tools toolbox. Our target feature is going to be our Little Rock wards layer, and our join feature is going to be our address points. I'm going to call my output feature class Little Rock Wards Residential. Our join is 1-to-1, and you need to keep checked the keep all target features option. Our match option is intersect. And now we are going to do some field management because we don't need any of the data in order to create our core pleth map. We don't need any of the fields that are in the Pulaski County address point layer. So we're going to delete all of them from this field map so that they are not cluttering up the layer that we're going to use to create our thematic map. To do this, you should click X on every single field that is below the field called Bio. This is going to leave just 3 fields left in your field map. Once you have just these 3 fields in your field map, you can click Run. It shouldn't take too long for the spatial join to complete, and then you can examine your spatial join. So open the attribute table, and we can see if we open our original wards layer that it has 5 fields, and our new wards layer has a handful more. We have shape length and shape area. We have our district, our name, our bio field, and then we have a new field called join count. The field called join count represents the number of residential addresses that were joined to our ward. And the district is really our ward number. The City of Little Rock does not call wards districts, so we're going to change 2 of our field aliases so that it's easier for us to understand. So open up your fields view and change the join count alias from join count to, what did I tell you to change it to? Residential count. and change your district field alias from district to wards, and then save your changes. I'm also just going to, if it will let me, delete this name field and delete the bio field because we do not need those. Lastly, I am going to change the order of these fields because we are going to be using residential count and wards as we create our thematic map. Let's use select by location to check and make sure that the spatial join worked correctly. So open the attribute table for your Pulaski County address points and keep your Little Rock wards residential layer or the attribute table open. In the Little Rock wards residential table, we want to highlight Ward 1. And in our Pulaski County address point table, we want to make sure that we don't have anything selected. Next, in the Map tab, click on Select by Location. And our input feature is going to be our Little Rock wards. We want to know, using Select by Location, how many address points intersect with our wards. So actually, our input feature is going to be Pulaski County address point. And our selecting feature, we're going to select our address points by our Little Rock wards. And I'm going to go ahead and delete my old Little Rock wards layer because I don't need it anymore and it will reduce confusion. So in our attribute table, we selected Ward 1, and you can see in our Share by Location dialog box, when we use our wards layer as our selecting feature, it says that we can use the selected records. So this is going to select by location for all address points that are located in Ward 1. If we toggled this off, it would select all address points that are located in any of the 7 wards, which should just give us a result that is equal to the number of records in our address point layer. Okay, enough talking. I'm going to run the select by location. And that wasn't right because I had use selected records turned off. So now I'm going to clear my selection in the address points layer and click apply again. Now we will see that the select by location selected 14,812 address points in Ward 1. So click over to Ward 1, view your residential count field or your join count field, and if the number in the count field matches the selected number in your address points layer, you can feel pretty confident that the spatial join ran correctly and the rest of the join count fields will also be correct. Now that we have performed our spatial join and we have our residential count or our join count field populated, we no longer need our Pulaski County address point layer. I'm not going to delete it, but I'm just going to turn it off so it's not cluttering up my map view. The rest of the work that we're going to do is with our Little Rock wards residential layer. We are going to add 3 new fields. So go to your fields view and add a field called area. It should be a float data type. Add a second field called density. And it also should be a float type. Lastly, add a field called density R or residential density rounded. And this is going to be a short integer because it will not have any decimal points. Once you've added those 3 fields, click Save, and you can exit your fields view. Next, we are going to populate these 3 new fields. First, we're going to calculate our land area. To do this, make sure that you have no records selected, so click the Clear Selected Records button. And then right-click on your land area field and select Calculate Geometry. Our input feature should auto-populate to the layer that we're using, which is our LR Wards Residential, and the field should auto-populate as well to land area. We are calculating area, and we are going to use square US survey miles. So once you fill in those two drop-down options, click OK. And we can see that our land area field has been populated. Next, we're going to calculate residential density using the Calculate Field or Field Calculator. There's a bit more going on in this input table, or in this parameter dialog box for Field Calculate. So input table should auto-populate, as well as our field name. We're going to change expression type from Python to Arcade. Whereas Python is a coding language that is used by so many different types of software, Arcade is a coding language that is exclusive to Esri products, and it's used to do things like field calculate or create dynamic labels and create dynamic pop-ups. You can do a lot with Arcade. So after you've switched expression type to Arcade, we're going to fill in the calculation that we want this to perform. To find density, we want to divide our residential count field by our land area. And when you are filling out this field, you should not type in what I have in the instruction document. Instead, you should use this field option here, because your names for your fields might be slightly different. There might be, you might not have an underscore, or you might have called area something different. But you should be dividing your join count field by the land area field that you just calculated. Once you have that in your density box, click Apply, and we get our residential density. We don't want to use these values with decimals though, but we wanted to get decimals because our land area has decimals and we want to round up to the nearest whole number. So next, populate your residential density rounded fields, or populate the domains for this field using the rounded value of your residential density field. I have populated my 7 records with their rounded domain value for residential density, rounded. Now I'm going to click onto the Edit tab and click Save. This will save the edits that we just made to our attribute table. And then I'm going to go ahead and save my project. Now we are going to add categorical symbology to our Little Rock wards layer so that we can display this data as a choropleth map. To do this, you need to open the symbology pane. You can do that by clicking on the symbology icon in the content pane. And if you get to a symbology pane that looks like this, that shows you colors that you can change for your polygon, click the back arrow at the top left, and we are going to change our primary symbology from single symbol to graduated colors. Now you need to pay attention to the field that it is using to symbolize your data. We need to use our residential density rounded field. And I want you to decide what method and what number of classes you are going to use for your data classification schema. I'm just going to switch it to equal interval and change the classes to 4. But I want you to spend some time playing around with these different options to see how it changes the display of the data. And also, I would like for you to choose a color ramp or a color scheme that is preferably one color so that it is easier for map viewers to determine which wards have the highest residential density. You also need to make sure that your color scheme is cartographically pleasing against your base map. Once you have done this, it is time to label your layer. To do this, right-click on the layer in your content pane and click on Labeling Properties. And we are going to use a very simple arcade expression to label our 7 records in this layer. In this expression field, type quotes, double quotes, ward, include a space, and then close your double quotes, then add a plus sign, and then you can choose the wards or district field. And if you click apply, I need to turn my labels on. If your labels are not turned on, you can right click on the layer in the content pane and click label, and your labels will appear. So you see this simple arcade expression, we added a word, and then we're using the value from one of our fields. If you do not include a space here and you click apply, you can see that you're missing a space. Another option to add a space would be to do a double quote, a space, a closed double quote, and another plus sign. Either way works. The first option was just easier. Once you've set your labels for the text that you want, you need to change the symbol so that it is at the font style and the size and the font text or the font name that you want. And I would also like for you to add a halo to your labels. Once you have your categorical symbology and your labels the way that you like, it is time to create your map layout. To do this, you go to the Insert tab and you select New Layout. The landscaped letter size, I think, works pretty well for the size and shape of the Little Rock wards. When you're in your new layout, you can add a title using on the Insert tab using the graphics and text group. So add an appropriate title. That thoroughly explains what this map does. And remember, when you're in a text box, now you have a new tab up top in your ribbon, and here is where you can change your font size. And to add your map frame, you need to be on the Insert tab while you're on your layout. And you should add not the default extent, but your map extent. You can draw your map frame in. And then to change how your map is shown in the map extent, remember you have to go to Layout and click the Activate button in the map group. And here you will be able to zoom in and move your map around. And then once you're happy with where your map is at, which not great, but I'm just doing this as an example for you guys. Once you've got your map where you want it, click Close Activation. Don't forget that you need to add a legend and you need to add map credits. The instruction document outlines what information I want in your map credits. I would like for your map credits to be pretty thorough, and the rubric on the first page of the instructions lists all of the information that you should include in your map credits. So what you will get points on for your layout is having an appropriate title, having obviously a map extent, having a thorough, robust map credits, and having a legend. You'll also get points for the cartographic color choice of your graduated symbols, and you will also get points for your labels. I want to show you quickly how to change some information in your legend, because right now this legend is not very clear. So you can't change the text in the legend itself, but you can change the text in the content pane. And sometimes it can be a bit confusing. It is our LR Ward's residential layer that is in the legend. So we can change the name of that in our content pane, and it will update in the legend. So naming this layer something like residential density by ward gives us a good label in our legend, but now you can see that we have our field name is also listed in our legend, and that clutters it up and makes it a bit confusing for the map viewer. To solve this problem, you have to click on that field name in your content pane and delete it, and then it will go away. I just added a space, so it's leaving that space there. Let me see. As you can hear, I have to click like so many times to get that to pop up. It seems like it will not let it be completely empty. So to clear up any confusion, you can just leave a space in there, or you could change the title of this field to residential density by ward. Let's try that. Oh, I hate the legends. So much clicking for nothing. And let's see if we can leave this field blank, or the name of this layer blank. We can. So that solves our aesthetic and text problem for our legend. You should probably spend some time making the text of your legend labels a little bit larger, as well as the color icons. So once you have chosen your appropriate color scheme and labeled your 7 wards and created your map layout, you are done with this assignment. Thank you.